Good afternoon, dear colleagues, and I would like to present the subject of our investigation. This is exactly as you see the creation of the algorithm of the automated program of the airspace design. Well, the airspace design is an essential part of aviation system, and it is intended as implementation of instrument flight procedures and the system of routes available to guarantee a safe and orderly flow of air traffic. And these requirements for airspace design are published in document 8168. And of course, airspace design requirements will be differ for three main segments of flight, exactly departure, en route, and approach. And in our work, we consider exactly approach segment. The next, we know that there are four basic charts of the instrument landing approach. They are straight in approach, procedure tone, base turn, and racetrack. And here you see how they look like. And you know that for construction of certain approach chart, it is necessary to consider a lot of factors, and a part of which are derivative from other factors. So the calculations are rather complex and ambiguous. And we propose an algorithm for the program which will construct a racetrack approach chart. And of course, the first what the program should do is to define by what chart the calculation are performed. And here you can see that input parameters are initial flight level above the yaw and its length and angle of approach. And if certain condition that does not satisfy, we have straight in approach, then we have to consider the sector from which the aircraft is approaching the runway, and we have whether procedure tone, base turn, or racetrack. But despite racetrack itself is rather complex procedure, and we at first propose you it's the short algorithm which shows its main procedures, and they are construction of the simplified scheme of obstacle assessment zone, determination of the presence of significant obstacles in this zone, then it is exact construction of the obstacle assessment zone, and final calculation of the minimum safety altitude in this safety heights in this zone. So first let's start from the construction of the obstacle assessment zone. It has a rectangular form, and as you see, the coordinates of this rectangular depends on the outbound time and aircraft category. As we know, there are outbound time for 1 minute, 2 minutes, and 3 minutes, and aircraft category A, B, C, and D. And the result, all conditions are checked, and we supposed to receive obstacle assessment zones. You see that there are its main parts and arbitrary parts. But another one what we should check is, you see, we suppose that in our program the data about artificial obstacles would be downloaded from the database of this program, and we have to check whether in these zones are significant obstacles, and if we take them into account, that it would increase the boundaries of the rectangular zone greatly. So we check this and make exact calculation of the coordinates of the points. But still, each zone has not only horizontal boundaries but vertical also, and you see that to the right that we have to input such parameters as height of the maximum obstacle in the main part of the zone, that height of the obstacles in the arbitrary zone of this, and we will perform calculation of the minimum safety altitude. As a result, we are supposed to receive such racetrack scheme. You see rectangular, it is our minimum obstacle assessment zone. Here it is what we are supposed to receive. And as for conclusion, we hope that our proposed algorithm, which will be the important step for the creation of this program, because in Ukraine there is no such program, and as the amount of necessary input data is much larger during the calculation exactly of the approach segment, so we decided to choose exactly approach segment and make a step to make all these necessary calculations. Thanks a lot for your attention.